Hello students, let's learn some new things in chapter number 14. Symmetry. Topic rotational symmetry. In this topic you will learn a clockwise rotation, anticlockwise rotation, center of rotation, angle of rotation and order of rotational symmetry. Rotational symmetry means there is a one shape there in its position. When you rotate that position with one center of rotation for some certain angle, after rotating, if you get a same shape which was at the first place, then you can say that this shape has a rotational symmetry. For example, we will take a shape of windmill. To explain this part, I have made one paper windmill. So here, from this paper windmill, we will learn about the rotational symmetry. Rotational symmetry means there is a one center of rotation. Here, the center of rotation is this point, the point where I have put my tip of the pencil. So this is called a center of rotation. Now, we will rotate this paper windmill. Now, as you can see, I am rotating the paper windmill in the direction of the clock hands, and this is called a clockwise direction, that is clockwise rotation. And this other way rotation, this is called anti-clockwise rotation. So here in first figure you can see that a figure of paper windmill, and at the one point of the paper windmill, that means this point, we have represented it with letter A. Now we will rotate this paper windmill to anti-clockwise rotation, that means this way. At certain angle, that means angle 90, we will get this figure, and this figure is look exactly like the figure which at first place, that is original figure. So this is called a rotational symmetry for this figure at angle 90. We will continue this rotation. Now we will continue again same angle 90 in anti-clockwise direction. We will get this shape. A second time anti-clockwise direction, this A vertex came here, then again this A point comes here, then here, and again at its original position. So here this paper windmill, you can see that each 90 angle rotation, we can see the exact same copy of the windmill at its original position. So here at 90 angle we get this one, again 90 we get this figure, again 90 this, and again 90, the windmill gets at its original position. So total rotation, what how much rotation we have done in totality, we can count it. 90 plus 90, that is 180, 180 plus 90, that is 270, 270 plus 90, that is 360. So full rotation is called 360 degree rotation, half rotation is called 180 degree, and quarter rotation is called 90 degree. So here for this windmill we have rotated into anti-clockwise direction at quarterly position, that is quarterly rotation, 90 then 90 and so on. So we can say that how many times we have rotated, that is 1, 2, 3 and 4. So we can say that this figure has order of rotation, order of rotational symmetry 4. Next we will check a rotational symmetry for a square. So here we will use a paper square. This is a center of rotation. Now we will rotate this square clockwise. So after rotating at the angle 90, we will get this shape. That is, here we have take one point, one vertex of the square as point P. When we rotate at 90 degree, the point P will come here, and this figure is looking exactly like the figure at the first place, that is original figure, and that's why it is a rotational symmetry. Now again we have to rotate till we get the original position of the figure. So now again we will rotate for a 90-degree angle, we will get this figure. Again we will rotate, we will get this figure, and again we will rotate, we will get the original figure. So here we can see that how many times we have rotated. This is 1, 2, 3 and 4. After 4 rotation we get the same figure. So here we can say that square has a rotational symmetry of order 4. Here center of rotation is this one, this cross sign. In every figure you will see the cross sign, this kind of cross sign. The intersection point of this two line segment, this cross point, it is a center of rotation. Angle of rotation for square is 90-degree and order is.
Okay, let's solve exercise 14.2. Question number 1. Which of the following figures have rotational symmetry of order more than 1? So here, figure number A. So in this figure, the circle is given, and in this circle there are two diameters are there, 1 and 2, which are perpendicular to each other. That means here between them there is an angle 90, and we have to find the rotational symmetry for this figure. So now for that, first of all, what you have to do, you have to find one end point. So here in a circle there are total 4 points are there because of these diameters 1, 2, 3 and 4. So in this, out of these 4 points we have to take 1 point. Now to be this figure, while we rotate, to be exact copy of the original figure, it's this point P should have to become on these other 3 points. So we will start with clockwise rotation. So clockwise we will rotate this figure. So from point P, and this is a center of rotation. Now we will rotate the figure in a such a way that this point P come in this point. So when we rotate at a certain angle in clockwise direction, this point P comes here, and when we compare these two figures, we get the same figure. So that's why this is our first rotational symmetry. So what is the angle, rotation angle? So as we know that between these two diameters, they are perpendicular to each other. Therefore, angle of rotation, it is 90-degree. Again, now we have started a clockwise direction rotation. So we have to do the same way. So now from here we will rotate the figure for a 90-degree angle. Now when you get the angle of rotation, that same angle of rotation we have to do. So here again with 90-degree rotation we get the point P here, and therefore here also we are getting same figure as original. So this is our second rotational symmetry. Then again we will rotate for 90-degree. The point P will come here, same clockwise direction rotation, and again same clockwise direction rotation at 90-degree. We get our full rotation will complete, that is 360-degree. We get the original figure. So how many times we have rotated and we get exactly same figure? It is 1, 2, 3 and 4, and therefore this figure have rotational symmetry of order 4. Order of rotational symmetry, it is 4. Angle of rotation, it is 90-degree. And if we say what is the direction of the rotation, so we can say it is clockwise direction.
Number B. Here figure of equilateral triangle is given, and now we have to find order of rotation, rotational symmetry for this figure. So here, now in this triangle there are three vertices, 1, 2 and 3. So here we will take one vertex as point A. Now we will rotate this triangle in a certain way, that means clockwise direction, so that this A point comes at this position, that means here. Now when we have rotated, we can see that these two figures looks exactly same, that means this is a rotational symmetry. Now we will find the angle of rotation. To find that, what we have to do, we have to use protector, and at the center of the rotation we have to put our this point of protector, that is center of the protector. Now at one line, that means at 0 degree angle, we have to take this point A, and now we can see that at which degree we are rotating this point A, it comes at this point. That means what is the angle? That means this angle, it is 120. So after rotating at 120 degree angle for this triangle, we get rotational symmetry. Again we have to rotate this shape until we get original position. Again we will rotate this shape at 120 degree angle. This point will come A, will come here, and again when we rotate at 120 degree, we will get the A point as here, that means original position. So rotational symmetry, order of rotational symmetry is 1, 2, 3. That is 120 plus 120 plus 120. That is full rotation, that is 360. So order of rotational symmetry for this shape is 3. Next, see. Here this shape is given. Now we will take this point as a point P. Now we will rotate. If we rotate this point to make this point at this point, we will rotate this shape in a such a way that this point P comes in this place, then we can get not exactly shape. That means this, the square boxes, we can see after rotating at 180 degree angle. This is 180 degree angle. This square box will come. We can see these are at this place, that is inverted place. So it is not a rotational symmetry. So what we have to do, we have to again rotate, and when we again rotate 180 degree, that means full rotation, we will get a shape in original position. That means after rotating at 360 degree rotation, we get this same shape. That means this shape has a rotational symmetry of order 1. D. Here this shape is given and center of rotation is this. Now we will take one point Q and now we will rotate. Now you have to imagine that you are rotating this shape. When you rotate this shape, now what you have to do, you have to rotate this shape in a such a way that this point Q will come here. Now when this Q point will come here, these lines will rotate this way, and that shape will not look exactly like the original shape, as it will look like a letter I. Again we have to rotate. Now here Q is there. Again we are rotating in a certain way that this Q comes here. So this is this figure. So here we can see that these two figures looks exactly same. And what is the angle of rotation? Angle of rotation is nothing but what we have rotated. We have rotated this much, and this is what, 180 degree. You can use protector to see 180 degree rotation. When you do 180 degree rotation, this Q comes in this place and these two shapes looks exactly same. Again we will do a 180 degree rotation, we get the shape, original shape. So order of rotational symmetry for this shape is 2. That is 180 degree rotational 1, and then 180 degree rotational again, it is 2. Order of rotational symmetry is 2. By this formula you can find order of rotation as, what you have to do, full turn, that is 360 degree, you have to divide 360 degree by the angle of rotation, that is 180. For this shape it is 180. 360 by 180, 0 0 cut, 18 to the 36. So answer is 2, and this 2 is nothing but order of rotational symmetry, 2. Next, E. Here circle is given, it has 3 line segments, that means 3 radius line segments, 1, 2 and 3. Now we have to rotate. So here we can see that because of this line segment we can identify 3 points on the circle, that is 1, 2 and 3. So for one point we will take that point as point R. Now we have to rotate this shape in a certain way that this R comes in this place, that means here. Now how much we have rotated? That means this much. Again we will rotate this shape in this way, we will get R here, and again when we rotate this shape we will get the shape, the original shape. So here how many times we have rotated? That means 3 times. The order of rotational symmetry is 3. Now what is the angle of rotation? So what for angle of rotation, if we want to find, what we have to do, we will use this formula. Angle of rotation is equal to 360 divided by order of rotational symmetry. So that is equal to 360 divided by the angle of order of rotational symmetry for this shape, it is 3. So 360 divided by 3, as we know that 3 12s are 36. This 0 will cut and it will come here. So what is the answer? That is 120, and it is degree, it is angle. So angle of rotation for this shape, it is 120. 120 plus 120 and plus 180, that is full turn, that is 360. Next, F. This shape to already we have done. It is a shape of paper windmill, and already we have done that. What is the angle of rotation? That is 90, and order of rotational symmetry is 4. So again we come to the question 1. Question was, which of the following figures have rotational symmetry of order more than 1? We have seen each and every shape, and from that only one shape, that is shape number C, is only shape which have rotational symmetry of order 1, not more than 1, and other shapes, all the shapes have order of rotational symmetry more than 1. That is answer is, that is A, B, D, E and F. These 5 shapes which we have seen, they have order of rotational symmetry more than 1. Give the question number 2. Give the order of rotational symmetry for each figure. Question number 2. A. First figure. Here we have to find the rotational order of rotational symmetry for this figure. So here we will take this one point as point P. Now we have to rotate. Here we can see that in this shape there are only 2 points, 2 end points are there. That means this point and another point is this one. So now we will rotate this shape in such a way that this point P comes in place of this point. That means here. So here we can see that these 2 shapes looks exactly same. So this is the order of, this is a rotational symmetry for this shape. Now, so how much we have rotated, that is what is the angle of the rotation for this shape? That is nothing but we have rotated this shape this much, that is 180 degree rotation. Again we will rotate this shape again at 180 degree, we will get exactly same shape, that is 180 plus 180, it is 360. The order of rotational symmetry for this shape, it is 2. 180 degree, 180 degree rotation, another 180 degree rotation. We can find by directly the formula, that is 360 divided by angle of rotation, that is 180. 360 divided by 180, it is 2. So order of rotational symmetry is 2. Next shape, here 2 lines we can see here, and here between these two lines one angle is given, that is 80 degree. Here there are 4 endpoints are there in these line segments. So one endpoint we will take it as A. Now we have to rotate. First of all, we will rotate this shape, and here angle of rotation is this place. So from here, from this point, we have to rotate the shape. So we will rotate this shape in such a way that this A comes here. Now whenever A comes here, this angle will become 80 degree, and that shape will not look like same original shape, because this is which angle? It is 100. As we know that these two are linear pair. Here 80 degree, the other angle will be 100. So again we have to rotate this point. Here A is there. Again we have to rotate for a certain angle that we can get A at this point. That means here. And now we can see that these two shapes, they look exactly same, as 80 degree there, and its vertically opposite angle would be 80 degree. So that's why these two are 80 degree angle and these two are 100. So these two shapes looks exactly same. And what is the angle of rotation? That is first 80 and then 100. That is full rotation. It is 180 degree rotation. Again we will do 180 degree rotation. So we will get the exactly original shape. So what is the order of rotational symmetry for this shape? It is 180 and again 180. That is 2. Next, see, this is a shape of equilateral triangle, and already we have discussed. We will take this one point A. Now we will rotate this shape in such a way that this A comes in this position, that is A, and again we will rotate this point in such a way that A comes in this position, that means here, and again we will rotate, then A will come in its original position. So here we have rotated 3 times. So order of rotational symmetry is 3. And what is angle of rotation? Again 1 rotation, second, and when we rotate again we will get this same shape, that is 1, 2 and 3. So order of rotational symmetry is 3 and angle of rotation is 120. 360 divided by 3, 3 12s are 60, 0 cut 0 comes here, so it is 120. So 120 degree is the angle of rotation for this set, for equilateral triangle. Next, D. Here shape is given. We will take one endpoint as point P. Now we will rotate this point P that it comes in this position, that means here, and we can see that these two shapes exactly look same. So what is the angle of rotation? So this is the angle of rotation and it is nothing but 90. Again we will rotate this shape so that P comes here, so it is angle of rotation on 90. Again we will rotate this shape in such a way that P comes here, angle of rotation 90, and again we will rotate this shape in the same direction. We are rotating in clockwise direction and we have to rotate only in clockwise direction. So again we will rotate in 90 angle, we will get this same shape. So how many times we have rotated? 1, 2, 3, 4, each time 90 degree rotation. So order of the rotation symmetry for this shape, it is 4, and angle of rotation it is 90. Next, E. Here we will take one point Q. Now we will rotate. Now we have to rotate this point Q in such a way that it comes in this position. So here, what is angle of rotation? Angle of rotation is nothing but this one, that is 90. Again we will rotate. Here we will write Q. Again we will rotate such a way that this point comes in this position. In this position, that is Q. Here, again we will rotate in such a way that Q comes in this position, that means here it is Q, and again we will rotate, we will get the exactly same shape. Again Q, rotate in such a way that it gets here. Now again rotate such a way that that point comes here, that is here. Again such a way, rotate, that is 90 degree angle, we get Q here, and again at 90-degree angle we will get a same exactly shape. So order of rotational symmetry for this shape is 4 and angle of the rotation it is 90. Next one, it is a regular pentagon. So we will take one point, that means one vertex of the pentagon as point A. Now we have to rotate in such a way that next point, where is next vertex? It is here. So this shape comes in this shape. As we can see that it is a regular pentagon. All the sides are equal. When we rotate this shape here, angle of rotation is marked here. Here in center of the pentagon, that is center intersection point of the diagonals, it is a rotational, it is a center of rotation. From that we have to rotate, and we have to rotate such a way that this A comes here. Again we have to rotate in such a way A comes here. Again we have to rotate such a way that A comes here. Again we have to rotate such a way A comes here, and again we have to rotate such a way that A comes in its original position. So how many times we have rotated? That is 1, 2, 3, 4 and 5. So 5 times when you rotate this shape, you will get exactly same shape. So order of rotational symmetry is, for regular pentagon it is 5. Now we will find angle of rotational symmetry. That is equal to nothing but 360 divided by order of rotational symmetry, it is 5. We will divide the 360 divided by 5, we will get 72. So angle of rotation is what? 72 degree. Again we can rotate 72, again 72, 72 5 times. At the angle of rotation 72 degree we have to rotate this regular pentagon. We get each and every time exactly same shape. Therefore order of rotational symmetry for this regular pentagon it is 5 and angle of rotation it is 72. Next, shape G. Shape G and H are quite difficult to draw, so we will see these shapes directly from the textbook. So here we will take this point as a point P. It is a shape of a star. This is center of the rotation, and now we have to move this P. We will rotate this shape in a clockwise direction, that's such a way that this P comes in this point. Now as we can say that all the end points and all the line segments we can see here, these are looks exactly same. And when we rotate this shape in a such a way in a clockwise direction that this P comes here, we get exactly same shape. Again we have to rotate that P comes here, again we have to rotate that P comes here, again we have to rotate that P comes here, again we have to rotate that P comes here, and again we have to rotate that P comes in its original position. So how many times we are rotating? 1, 2, 3, 4, 5 and 6. So rotational symmetry for this shape it is 6. And what is the angle of rotation? It is nothing but 360 divided by 6. As we know that 6 6 are 36. So angle of rotation for this shape it is 60 and order of rotation it is 6. Now next, this shape. So here we have to take one point. We will take here this point as a point A. Now we will rotate in such a way that A comes here, another point is here. So when we rotate this thing, we get exactly same shape. Again we have to rotate that A comes here, we get exactly same shape, and again we have to rotate that A comes in its original position. So here we can see that how many times we have rotated. That means 1, 2 and this is 3. So 3 times we have rotated, and in these 3 times we get exactly same copy, and that's why order of rotation for this shape it is 3. And what is the angle of rotation? That is 360 divided by 3, and it is nothing but 120 degree. So for shape G, order of rotational symmetry it is 6, and for shape H, order of rotational symmetry is 3.